Imagine a future where a tiny chip in your brain can help you control your devices, or even restore lost functions due to a disability. Sounds like science fiction, doesn't it? But with Neuralink's first human implant, we are one step closer to turning this fiction into reality. This leap forward signifies the dawn of a new era in neurotechnology, marking a major milestone in brain-computer interface research. This is not just about controlling gadgets with your thoughts or having a supercomputer in your skull. It's about potentially revolutionizing medical treatments, enhancing human capabilities, and even redefining the way we interact with technology. The promise of this new realm of possibilities is both thrilling and daunting. As details continue to unfold about this first human implant, we find ourselves on the precipice of a technological revolution. As we delve into this groundbreaking development, keep in mind, we're on the brink of a new era in neurotechnology. What makes this implant so revolutionary? It's all about neuron spike detection. Neurons, the fundamental units of the brain, communicate through electrical signals. These signals, or spikes, are the brain's way of transmitting information. The ability to detect these spikes is a crucial aspect of brain-computer interface, or BCI technology. So when we talk about Neuralink's successful neuron spike detection, we're talking about a significant breakthrough. But what does this mean in practical terms? Well, think of the brain as a bustling city with neurons as its inhabitants. Each neuron, like a city dweller, has its own unique pattern of activity. Now imagine if you could listen in on these conversations, understand what's being said, and even participate in the dialogue. That's the promise of neuron spike detection. By picking up on the electrical activity in the brain, Neuralink's implant essentially tunes into these neuronal conversations. It's like having a radio that can tune into different frequencies, each representing a different group of neurons. This ability to listen in and decipher the brain's electrical activity is a game changer. It's the foundation upon which all future BCI applications will be built. Now, it's important to note that this is only the first step. Just as understanding a language doesn't necessarily make you fluent, detecting neuron spikes doesn't automatically translate to interpreting or influencing them, but it's a start. And sometimes the first step is the most important one. As we look towards the future, the implications are staggering. If we can not only detect but also understand and influence these neuron spikes, we could potentially communicate with the brain in its own language. This could open up a world of possibilities, from treating neurological disorders to enhancing human cognition and beyond. So, while we're still in the early stages, the successful detection of neuron spikes by Neuralink's implant is a promising development. It's a significant stride towards a future where we can interact with our brains in ways we've only dreamed of. This promising development could be the key to unlocking the full potential of BCI technology. Scene script. Neuralink's vision extends far beyond simply controlling devices. They see a future where their technology can transform lives. Indeed, Neuralink is not just a tech whiz's dream of telepathically tweeting or playing video games with your mind. It's a beacon of hope, lighting the way to a future where paralysis, neurodegenerative diseases, and even mental health disorders could become things of the past. Neuralink's technology promises to tap into the brain's electrical activity, potentially paving the way for a myriad of medical applications. One of the most compelling applications lies in restoring mobility for paralyzed individuals. Imagine a world where a person with spinal cord injury could walk again, just by the power of their thoughts. Neuralink's implant could act as a bridge, bypassing the damaged area and sending signals from the brain directly to the muscles. This could give paralyzed individuals the chance to regain control of their bodies, and with it, a significant slice of their independence. But the potential doesn't stop at restoring mobility. Neuralink's technology could also be a game changer in the treatment of neurological disorders. Conditions like Parkinson's disease, epilepsy, and even depression could be mitigated by fine-tuning the brain's electrical activity. The implant could act like a pacemaker for the brain, regulating abnormal signals and alleviating symptoms. This first human implant represents a significant step towards realizing these therapeutic applications. Although we're still in the early days, this groundbreaking development could soon pave the way for clinical trials. The data gathered from these trials will be crucial in advancing our understanding of the brain and how we can harness its power to combat debilitating conditions. Neuralink's vision is ambitious, to say the least. But if successful, it could herald a new era in healthcare where we're not just treating symptoms, but addressing the root causes of disorders directly at the source, the human brain. We might just be witnessing the beginning of a revolution in healthcare. With great power comes great responsibility, and this is certainly true for BCI technology. While the breakthroughs in brain-computer interface technology are undeniably exciting, they also bring forth a host of ethical questions that we must consider. The key concerns revolve around privacy, data security, and the potential misuse of brain information. Let's start with privacy. With devices like Neuralink's Implant, we're talking about a technology that can literally read minds. But who gets access to these thoughts? And what happens if they fall into the wrong hands? These are not just hypothetical questions, they are real issues that we must address as we continue to develop and refine this technology. Next, let's talk about data security. As with any digital technology, BCIs are susceptible to hacking. Imagine a scenario where a malicious actor gains unauthorized access to a person's neural data. The consequences could be devastating, both for the individual and for society at large. Therefore, it's crucial that we invest in robust security measures to protect this sensitive data. Lastly, there's the concern about the potential misuse of brain information. With BCIs, we're not just dealing with mundane data like browsing history or shopping preferences. We're dealing with the very essence of who we are, our thoughts, memories, and emotions. The potential for misuse is vast, from unconsented behavior manipulation to the commodification of our innermost thoughts. To navigate these issues, careful regulations and open discussions are absolutely necessary. We need to create a framework that ensures the responsible development and use of BCI technology. This includes stringent guidelines for data handling, robust security measures, and clear policies on data ownership and consent. Moreover, it's important that these discussions are inclusive, involving not just scientists and policymakers, but also the wider public. After all, this technology has the potential to affect us all. As we venture into this new frontier, it's critical that we navigate with caution and conscience. Neuralink isn't the only player in the BCI game. Indeed, the field of brain-computer interfaces is hotly contested, with companies like Synchron and BlackRock Neurotech also making strides. These companies, much like Neuralink, are pushing the boundaries of what's possible, each contributing their own unique approach to this exciting field. Synchron, for instance, is developing the Stentrode, a device designed to be implanted into blood vessels in the brain, avoiding the need for invasive surgery. Meanwhile, BlackRock Neurotech has been pioneering neurotechnology for over 2 decades, with products designed to record, analyze, and interpret neural signals. The competition among these companies is driving innovation at an impressive pace. Each new development brings us closer to a future where brain-computer interfaces could become commonplace, changing the way we live, work, and interact with the world around us. But it's not just about healthcare. The potential applications of BCI technology extend well beyond medical treatments. Imagine, for example, a future where we can communicate telepathically, using nothing but our thoughts, or consider the possibilities for immersive entertainment. Virtual reality could become truly virtual, with users able to interact with digital environments as naturally as they do with the physical world. These are just a few of the possibilities. With continued research and development, the potential applications of BCI technology are virtually limitless. As we continue to explore and understand the intricacies of the human brain, we're opening up new avenues for innovation, pushing the boundaries of what's possible. Of course, it's important to remember that we're at the beginning of this journey. There's still much we don't know, and plenty of challenges to overcome. But each step forward brings us closer to a future where the line between our brains and our technology becomes increasingly blurred. The race is on, and the finish line could change the world as we know it. So, where does this leave us? Let's take a moment to reflect. We've delved into the heart of a groundbreaking journey in neurotechnology, the first human implant from Neuralink. This significant milestone has demonstrated promising neuron spike detection, a critical step in brain-computer interface functionality. We've also explored the potential medical applications of this technology, including restoring mobility for paralyzed individuals and treating neurological disorders. But it's not all smooth sailing. We've touched upon the ethical concerns that come with such advancements. Privacy, data security, and potential misuse of brain information are all valid concerns that warrant careful regulation and open discussions. We've seen that Neuralink is not alone in this race. Companies like Synchron and BlackRock Neurotech are also pioneering advancements in BCI technology. The future holds exciting prospects extending beyond healthcare to communication and immersive entertainment. The journey has just begun, As we watch this new chapter in neurotechnology unfold, one thing is clear: the future is closer than we think.